It's a common core topic. It's under algebra. Algebra and polynomials. P for understanding polynomials. And it says understand that polynomials form a system analogous I can never say that word very well. Analogous to integers. Okay, so what it means basically is we've got to have whole number exponents, right? So let's look at example 1, right? So first of all, it is not in descending order. The proper way to write every polynomial is the biggest exponent first. So I'm going to rewrite p of x. Biggest exponent first. I'm going to write the 3x cubed first. 3x cubed minus the 10x squared plus the 4x plus 5. Okay? Now it's in order from biggest exponent down to the smallest. Okay? What is the degree? The degree is the biggest exponent. The degree is 3. Okay? The degree is 3. That's it. It's the biggest exponent. So the degree is 3. The leading coefficient is also 3, just in this case, only because there's a 3 there. So leading coefficient is also 3, because it's the number in the front. It leads the whole pack. And the constant is the 5, because it doesn't have a variable with it. It doesn't change, so the constant is just the 5. Now, P of 3 is just, it says it's just an expression. Plug in 3, okay? So P of 3 means to plug in 3, so P of 3 would be, well, let's see, that's a 3 times a 3 cubed minus 10 times 3 squared plus 4 times 3 plus 5. And I really like my calculator because I really do not want to do this by hand. So I'm just going to plug it in and go 3 to the third power, right? Minus 10 times 3 squared plus 4 times 3 plus 5, right? So just plug it in let your calculator do the work, plug it all in, and I get an answer of 8, okay? So P of 3 is 8. P of 3 is 8. What does this represent? It's just a point. It really is, because you made an x value of 3 and you got an answer of 8. So it's just a point. What does this represent? It is a point on the graph, on the squiggly graph. It is a point 3, 8 somewhere along this squiggly graph. That's all it is, okay? End behavior. Well, to know something about end behavior, we could graph it. We could. But we also know this. Because it's a positive 3x squared, it's going to finish up. Does that make sense? It's going to finish up because that's a positive 3x cubed. If this were negative, it would finish down, right? So we know end behavior has to be this. We know that as x approaches infinity, y goes to infinity. So as x goes to infinity, y goes to infinity. Now it's an x cubed. Now here's the thing about an x cubed. X cubes, we've seen x cubes before. X cubes look something like this. They do. We've seen an x cubed before. So as x goes to negative infinity, that way, where's y going? To negative infinity. Now we can always graph this on a calculator, right? We can always take a look at it because you're just taking my word for that. Yeah, that looks something like that. So let's graph it. Why not? Let's just take a look at it. Clear. Let's go y equals. Let's just graph it and see what it looks like. So I'm going to go ahead and do my 3x to the third minus 10x squared plus 4x plus 5. And let's graph it. Okay, there it is. And what do you know? It looks just like I said it would, right? Well, get it out of the glare. Okay, there it is, right? End behavior, it's going off to infinity. It's going down to negative infinity, right? You can see that. Example 2. Find the zeros Then graph the polynomial without a calculator. Ooh, without a calculator? Oh man, I think I can handle it. So first of all, let's factor. Let's factor. No calculator. How are we going to do this without a calculator? Let's factor. So if it's a 0, set it equal to 0. Okay? If it's a 0, we set it equal to 0 to find the values of x that make it 0. Well, I'll give you a hint. It's the F word. Does anybody know how to factor besides me? Any ideas? Anybody have any great ideas what we should do first on factoring this thing? Take out an x. Let's take out an x. They all have an x in common, so take out an x. So I'll have an x squared minus a 2x minus 3. Good. Okay, great. Now it can be factored again. It can be factored again. Anybody have any bright ideas besides me?
Pull out another.
Can't.
It would be 2 sets.
Nice. I heard it a couple of different times, right? X minus 3, x plus 1 is awesome. Why are they right? Because he's smart. Yes, Wyatt is smart. But we know that negative 3 times 1 is a negative 3, right? And if we add them up, we get the negative 2, right? But we're not done. We have to solve for x. So we are going to get 3 answers. We will get 3 answers. I knew we were going to get 3 answers because I knew if it was x cubed, I'd have 3 answers. Okay, so now one answer is 0 equals x. That's an answer. The other is 0 equals x minus 3. Then if I add the 3, one answer is 3, right? And then 0 equals x plus 1, right? But if I bring over the 1, I get a negative 1, okay? So, now let's graph it. Well, these are zeros. I'm going to just do a little graph right here. I don't have to be perfect on it, but I can get pretty much the right shape. I know, let's put a negative 1 here, 0, 1, 2, 3, okay. I know I'm going to have a 0 here, I'm going to have a 0 here, and a 0 here, okay. Now I know it's squiggly, right? It's a squiggly line, that kind of thing. But think about this. What do I know about end behavior? Where's it going to go at the very end? It's going to go up, okay? So I do know that it's got to cross through this point here and go up. And that has to happen, right? Totally agree. It's got to go through this point and go up. Now, it's also got to go through this point, right? So it's going to come like this. Now, it also has to go through that point, right? And then it has no other place to go but down. Has to look like that. We don't know its corresponding y values. We don't need to. We just need to get an idea of what it looks like, okay? So we just used a little bit of common sense. We were able to just squiggle it through, right? Okay. Example 3. Graph this without a calculator. Okay. All right, let's see what happens. So first of all, let's find the zeros. Well, this one's already factored. It's already factored. So we don't have to worry about that. So we'd have one answer, 0 equals x squared. We'd have an x answered x minus 2 cubed equals 0. And we'd have an x plus 1 equals 0, okay? Well, x squared really is like 2 different x's, right? So you're going to get x equals 0 and x equals 0 twice. This is what we call a double root. So what we call a double root. So it happens twice because of the x squared. You have to have 2, 3, 4, 5, 6. We're going to get 6 answers. We are. Okay? We're going to get 6 answers. Now this is a double root. Here's my double root right here. My double root happened right there. 0 happened twice. Okay? We're going to get a triple root also because of the cubed. So if I solve this, I really kind of have like an x minus 2 equals 0, x equals 2. But that happens 3 times because of the x cubed. So I have x equals 2, x equals 2, x equals 2. Even though it's the same thing 3 different times, that's what we call a triple root, okay? That happens 3 times, okay? All right, so minus 1, x equals negative 1. That just happens once. That's a single root, okay? All right, now let's see if we can graph this without a calculator, using a little bit of common sense, hopefully. Okay, so let's put in 0, -1, and 2, okay? Okay, so end behavior. What's going to happen? End behavior. It's going to go up because everything's all positive. You guys agree if you multiply it all the way through, it's going to be positive. Your very first term is going to be a positive x to the 6. So it does go up. You're totally right, Will. It goes up, okay? Now, everybody's got to watch this, okay? You got to watch this. It's got to go through 2, 3 different times. So you already goes through 2. So it's going down, then goes back up, goes back down again. Ready? Goes through 2, going down, goes back through 2, going up, goes back down, 2, going down. Happened 3 times. So it goes back down. Okay, at 0, then it's going to come to 0. And at 0, it's going to go through 0, going up, and then it's going to come back down 0 because it has to happen twice. So it goes through 0, going up, and then coming down. That's a double root. And now at the 1, it's just going to go through once. That's what this one's going to look like. Crazy, huh? Yeah. If you don't believe me, put it on your calculator. You can check it, okay? But I know I'm right.
Why would you do that?
Huh?
Why would you do that?
Because it has to go through it 3 different times. It has to go through it twice. So it's like touch and go, isn't it? Touches it, goes back down. So if it goes through it twice, it goes through this point. And then how can you go through a point twice? Well, it goes through it, going up, and comes back down to it coming down, okay? Weird, huh? Okay, turn the page. Okay, now, we've done this before. Find the zeros and the local maxes, local mins. So let's graph this one. This says on the calculator. So this time, hallelujah, let's use the calculator, right? So y equals, clear that.
Davies, I just graphed the last problem on my calculator. And like,
It's exactly what I had, isn't it? Isn't that
Yeah.
crazy? I know. You'd wonder if I know what I was talking about, huh? There are days you're like, I think he knows what he's doing, huh? Okay, x to the 4th power, right? Plus x to the 3rd power minus 16x squared minus 4x plus 48. Now, whenever I graph these things, I usually try and do a normal standard window. Standard window. And the standard window for me is just so you know the -10 to 10 and -10 to 10. Now there's a button in the zoom 6. If I go zoom 6, look what it says, standard, right? It'll automatically put your calculator standard window, -10 to 10, -10 to 10, okay? It's faster than going into your window and typing it in, okay? So I found this in zoom, and 6 says standard, okay? So we'll automatically make it go from -10 to 10, -10 to 10. Boom. Okay, let's graph this, see what it looks like, okay? So I've got a picture of it, but now I know which way to stretch, right? I need to go up, and I need to go down, right? So I go to my window, and let's stretch the window. The x's are fine, but the y's, let's go down. How about -20, +20, right? Play around with it, see what I get. Graph, boom. Okay, I got to stretch it some more, right? Got to stretch it some more, so maybe I'll go, okay, window, maybe -30 to 30. Graph it again. Hey, that's probably almost there, but I got to go up more, right?
50 works.
Okay, let's go 50 then. Window. So on the Y max, let's go 50. Cool. There it is, right? So now, let's go ahead and take a look at our max and mins. Okay, so we know how to do that, right? Calculate minimum, right? Left bound. Now, it is real important. This one shows it really well because there's 2 minimums, right? There's 2 minimums, so you got to tell the calculator where to look. So I go left bound.
Which one are we?
I'm going for that one down there. Yeah, that min. Enter. Enter. Now I know it's supposed to look. See the arrows? It's supposed to look right in here, right? It's supposed to look in there. Enter. So one of my minimums at -3.2. So I got a minimum at -3.2, comma, -31 is one minimum. And let's do the other one. So second, calculate, get the other minimum. Enter. We'll go. Da, 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 da. We're getting good at this, aren't we? enter, enter, guess. Okay, it's about 2.5, 2.5 comma negative 7.4. Okay, let's go my max. Second, calculate my maximum, right? Enter, da 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 da. We're getting it right. Over there somewhere. Enter, over here somewhere. Enter, boom. And we get about a negative 0.1, so my max is about negative 0.1 and about 48.2. I know, Trinity, we had a late start, so we're off, but glad you're here. So now, if we were to graph this thing, right, I can use my calculator. Sure looks like the zeros are at negative 2. There's a 0.
Calculator out of the way.
Oh, sorry, negative 2, negative 4, and at 2, and at 3, okay? And then we're just going to sketch it in, okay? It doesn't have to be perfect scale. So what, something like that. How's that? So good news, bad news. The good news is yes, you may use your calculator, okay? The bad news is on the quiz, I will sometimes ask you to do it without the calculator. Not the max and mins, but the zeros. When you get the zeros, that's just by factoring, and you will get credit for doing it by showing your work, okay? All right, how is that?